As a global organization with a long history, we've established Bruker as a trusted partner in the field of imaging and analytical solutions. Our commitment to excellence and innovation has earned the trust of our clients and partners worldwide. We take pride in our ability to deliver high-quality products and services that meet the evolving needs of the scientific and medical communities. Our reputation as leading provider of imaging solutions is built on years of experience and a deep understanding of our customers' requirements. Our expertise in X-ray imaging has positioned us at the forefront of the industry. We have consistently pushed the boundaries of what is possible, developing cutting-edge solutions that set new standards for performance and reliability. Our expertise is unmatched, and we continue to invest heavily in research and development to ensure that our products remain at the leading edge of technology. This dedication to innovation is reflected in our comprehensive portfolio of imaging solutions. Our range of instruments is designed to meet the diverse needs of our customers. From floor-standing multi-scale nano-CT instruments to benchtop micro-CT systems, we offer solutions that cater to a wide variety of applications. Our products are designed to deliver exceptional performance and reliability, making them indispensable tools for researchers in materials and biomedical research. The versatility of our portfolio ensures that we can provide the right solution for any imaging requirement. The non-destructive 3D imaging space is ripe for innovation, and we are excited to introduce our fourth-generation benchtop X-ray microscope. This new system represents a significant advancement in benchtop imaging technology, offering unparalleled performance and flexibility. I am proud to introduce the X4 POSEIDON, the first true multi-scale benchtop X-ray 3D microscope, designed to meet the needs of a wide range of users, from quality control to cutting-edge research.
For centuries, optical microscopy has given us a detailed view of the world. Bound to the surface, incapable of revealing what lies beneath. What if we could see inside? What secrets can we unlock? The time is now. Introducing the X4 POSEIDON, the essential 3D microscope. The power to see inside with a refined view. See objects in their totality, or focus on the most important detail. Unlock the power to not only see what lies beneath, but to imagine a whole new world of possibilities.
The X4 POSEIDON is a groundbreaking modular benchtop platform designed to revolutionize your workflow. This innovative system is fully configurable and allows multiple options for several components. This way, you can customize it to your specific needs. You can configure it as a workhorse solution with a reflection source and flat panel detector for screening studies, for example, but also as a high-end research solution with a 2-micron spot size transmission source and 2 different detectors. The modularity not only enhances flexibility, but also ensures that the platform can support future innovations, making it a long-term investment for your laboratory. Performance is at the heart of the X4 POSEIDON. It delivers excellent speed, a proven 2-micron resolution, and an impressive field of view. This ensures that you get the most accurate and detailed results. The advanced scanning modes further enhance your capabilities, allowing you to tackle a wide range of applications with ease. We are confident that this product will set new standards in performance and efficiency. Accessibility is another key feature of the X4 Poseidon. By listening to feedback from our users, we incorporated your suggestions to create a system that truly meets your needs. The hardware and software have a user-centered design. It makes it easy for novice users to get started and offers powerful features for experts. The software also supports multiple languages, ensuring that users from different linguistic backgrounds can fully utilize its capabilities. We also integrated a user and data management system that allows efficient handling of user information and data security. We hope that you will be as excited about these new features as we are, and are looking forward to seeing the fantastic work you will accomplish with the X4 Poseidon.
Hello, everybody, and welcome to our event. We're very, very excited to share the X4 Poseidon with you. This is something that a lot of work has gone into over time, and I'm happy to say I am joined here by two of the people that you just saw, Diederik Ellerbrook and Kjell Lapeer. So thank you for joining us here. So with that, just a little bit of logistics for the platform. On the side of your screen right now, everybody who's joined us, there is a Q&A panel. You might have to click on a tab called Stage, and you can type any questions that you have, and we will get to those right away. But while we're waiting for some of those questions to come in, let's kind of kick off the conversation. Let's start with you, Kjell. So tell us a little bit about what's unique and different about the X4 from the previous platforms that we've seen for Micro-CT and X-ray Microscopy.
Well, the previous systems or the current portfolio is really, you have the system as is. There are no options. Everything is predefined. You just add a workstation to it to have a fully functional setup. Now, that is completely different with the X4 Poseidon, which is developed now as a completely configurable platform. So for all the main components, sources, rotation stage, detector, you basically have the option between two different choices to tailor the solution depending on your needs.
So, and that platform concept, that's quite a bit different. I know traditionally some of the instruments are normally dedicated to kind of one side range or the other. Diederik, what's your take on that? Why is it important to have a concept like that where a system can be a little more extensible?
I'm not sure Diederik can hear us.
Well, Kjell, how about you take a bat at that one then?
Can you shortly repeat the question, John?
Sure. So the system is kind of a platform, and that's one of the very unique differentials here, that you can swap up components, that you can configure it to be, say, either better for resolution, better for coverage, speed, whatever the need is. Why is that important for people who are exploring X-ray microscopy?
Well, there are different samples, different analytical needs, and obviously also different budgets. So if you were to have a specific screening kind of application where you typically scan the same sample over and over again, or the same type of sample in a screening quality environment, you could perfectly go with a fixed setup where you go for a reflection type source in combination with a flat panel to ensure a smooth and continuous flow of results. But if you are in a multi-core facility, for example, and you have different customers with a lot of different applications, you can equip the system with two different detectors, and you go for low resolution fast scans, highest resolution scans with the CMOS detector. So you can really tailor it any way you want.
All right. And here in a second, I've got our other guest, Diederik, joining me.
Hi, John.
Hey.
Exciting times, right?
That's right. So we were just talking about the platform concept, and actually Kjell was giving us a little input on his take on why it's important to have a system, have a platform that has this extensibility to it.
Well, one of the important design goals that we had is to be ready for the future, right?
That's right.
I mean, it's all nice to buy something today that suits your needs, but ideally you want to extend that in the future and be ready for future innovation. And that's what we try to do, John.
Yeah. So now we do have a lot of questions that are coming in. So, and great, I'm so thankful that everybody here is enjoying things. So let's go ahead and start with the first one. And
Which is a good one.
yeah, let's start with this one. So Marcus is asking, which materials can we analyze and what's the limiting factors? The transmission coefficient, what's going on?
Gail, this is for you, I think, right?
Well, there are actually anything that fits inside can be analyzed, and that can be both life science samples as well as material science samples, going from the very smallest features to be imaged at the highest resolution, which is a sub-micron resolution. But you can also load quite big samples up to 11 centimeters in diameter like geological cores, for example, or big plastic parts. Um, that's the beauty of the system.
Great. Now, the next question that we have coming in from Jonathan here is, at the 2-micron resolution, how long does a scan typically take? Can you describe any size limitations for samples?
I guess
Yeah, you can take it, Gail. Go ahead.
Yeah, indeed. So 2-micron resolution, that's high resolution, and high resolution scans take time. There is always a trade of the higher the resolution, the longer is the scan. So give it half an hour, up to multiple hours if you really want to push out the highest resolution out of the system. If you go for low resolution, that will be in the sake of minutes.
All right. So the next one is actually a really interesting question. And this goes to this idea about microscopy and the general use. I like to say the ubiquity,
Yes.
actually, of micro-CT these days. So let's throw to Diederik. Is this similar to an
Well, I think it's a fantastic question because this is something that we aimed actually to put on the table when we launched the 3D X-ray microscope, right? So in the past, people have been using light microscopy a lot, right? And everybody still does. And nowadays, every second lab at SEM, be it benchtop or be it a big floor standing system, but those systems, they can image at very high resolution, but on the surface. Yeah, and with FIPSAM a bit below the surface. And we want to complement that technology with a non-destructive 3D imaging technology, which is the X4 POSEIDON. So no, it is different, but I would say there are very, very complementary techniques.
That's right. That's right. Now, we've got quite a few questions about the sample size. And I think this is probably a good time to address the idea that this isn't the only system in the Bruker portfolio of X-ray microscopes or micro-CT. The Poseidon is very versatile, it's very exciting, and that is the topic of today. But we do have other systems, too, that can do different sample sizes.
Gail, you want to take that one or shall I?
Sure. So we let me put it this way, that there are two extremes in the portfolios. We will have, for example, the SkyScan 1273, which accepts the largest samples in our portfolio, up to 30 centimeters in diameter and half a meter tall. That will be slightly less on the Poseidon system, so 110 millimeters in diameter and 300 millimeters tall. And then going even smaller, you have the current generation systems, the 1272, 1275. There you're really stuck with a lot smaller samples. Now, there is always a correlation between the sample size and the resolution, in a way that the smaller the samples are or can be cut, the higher the resolution that can be obtained. So to reach the very highest resolution, those are typically samples of only 1-2 millimeters in diameter, because of the physics of behind micro-CT.
All right.
Thanks, Gail.
So a question kind of on that scale of these instruments. So one question is the system transportable? What's the footprint and weight look like?
Well, transportable is a relative thing, right? I would say you cannot lift it with a few people. It's an X-ray system that has a maximum X-ray penetrating power of 110 kilovolts, so it has a lot of lead shielding. It weighs about 350 kilos, yeah? And in that sense, it is transportable. So we have users of our previous generation benchtop scanners that actually use those systems on the polar research stations, on icebreakers, in archaeological research. So yes, you can. And the system is built to be robust. Yeah. So that's a possibility.
Yeah. Yeah. And the one thing I'd like to emphasize is that even though the system isn't necessarily transportable, it is a reasonable size for our lab. So when we're talking about its footprint, okay, in the units, so I'm located here in Wisconsin, in the US, so we use inches. 10 feet. It's
You
a
do that, Joe.
Yeah, I don't know. It's a thing. It's about 3 feet, 2 feet, 2 feet. So 2 feet tall, 2 feet front to back, 3 feet to the side. And you can put it on right under about 1,000 pounds, maybe 800 pounds. So it can fit on a typical lab bench. In fact, here in the lab, we like to use benches that we could just get from a typical hardware store for these instruments. So they really can fit in any lab, and you don't need special power, things like that. It really is that ubiquitous technology. Now, we do have a lot of questions that have come in here, and we're not going to be able to answer them all right now. But if we don't get to them in the next session or in the product demo that's going to follow this main event presentation, then we will answer those questions. We'll send you guys out email to everybody. So with that, I would love to thank Kiel and Diedrich for joining us for this little mini session. And we're going to move on, and we're going to see the next part of the story.
Our team of engineers has worked tirelessly to push the limits of what can be accomplished in a benchtop system. By incorporating the latest advancements in technology, we have created a product that not only meets, but exceeds the expectations of our users. The integration of Gem Plus technology ensures that the X4 Poseidon delivers unseen performance and reliability, making it a superb addition to any laboratory or research facility. One of the key features of the X4 Poseidon is the high-precision rotary stage. It lies at the heart of the platform, making it crucial for achieving the level of accuracy and precision required. Our engineers have designed the rotation stage to be both robust and precise, available both with or without micro-positioning. The X4 Poseidon is built on a future-proof platform, which means it's designed to accommodate new technologies as they are emerging. This ensures that our users can continue to benefit from the latest advancements without needing to invest in an entirely new instrument. The hardware of our product is designed to be both powerful and versatile, with one system offering many configurations to suit different needs. This adaptability is a key factor in making our product a long-term investment for our users. In addition to its impressive hardware, our X4 Poseidon also features a completely new software package that integrates the full user workflow. This means that users can manage the entire process from start to finish within a single platform to streamline operation and improve efficiency. The software is also allowing users to add new features and capabilities as their needs evolve. Overall, the development of the X4 Poseidon has been a journey of innovation and dedication. From the initial concept to the final design, every aspect of the product has been carefully considered to ensure it meets the highest standards of quality and performance. We are providing our users with a powerful tool that can help them achieve their goals and drive progress in their respective fields of business and research.
The user experience of our X4 Poseidon is truly transformative. The system has been designed to cater to a wide range of application markets, including the pharmaceutical industry, energy storage, geology, mineralized and soft tissue research, plant and animal biology, and paleontology. Users from these diverse fields can now access advanced imaging capabilities that were previously out of reach, enabling them to conduct more detailed and accurate research. With the X4 Poseidon, we hope to make CT as commonplace as optical and electrical microscopes. One of the many standout features of this product is the adaptability of the hardware. The system is customizable to meet specific needs, ensuring that it remains relevant as new technologies and applications emerge. This flexibility is particularly beneficial for researchers who work across multiple disciplines, as it allows the use of a single system for a variety of tasks. The high speed of the X4 Poseidon is another major advantage, especially for screening studies and quality control environments where rapid data acquisition and processing are crucial. In addition to its high speed, the system offers high resolution, which is essential for scientific research purposes. Users can capture the smallest details, making it possible to conduct more thorough and accurate analysis. The large field of view further enhances the system's versatility, allowing users to analyze larger samples or multiple areas in a single scan. This combination of high speed, high resolution, and large field of view makes the X4 Poseidon an invaluable tool for a wide range of scientific studies. The ease of use of the all-new 3D X Suite software is another key aspect of the user experience. The intuitive interface simplifies the operation of the system, making it accessible to both novice and experienced users. Project management features help users stay organized and collaborate seamlessly with their colleagues. The fully integrated workflow from planning to reconstruction ensures that every step can be managed within a single platform, streamlining operations and improving efficiency. To accommodate users with varying levels of expertise, the system includes a protocol library for novices and full control options for advanced users. This flexibility allows you to grow with the system, enhancing your skills and capabilities over time. Overall, the user experience of the X4 Poseidon is characterized by its adaptability, high performance, and ease of use, making it an indispensable tool for researchers in a wide range of scientific fields.
All right. So now we are joined, in addition to Kjell and Diederik, we now have Jolien and Joris. So thanks for joining us. So Joris is actually part of our R&D team in Contact. So Joris, could you tell us a little bit about the development journey? I know you guys have spent a very, very long time on trying to bring this kind of freestanding system quality or floor standing system quality into a benchtop.
Yeah, it was an exciting journey, that's for sure. And it was a challenging one. And we put the bar very high, going for a new hardware platform and a new software platform. We were very proud of it. And in that process, we certainly had our challenges. And we definitely kept in mind is that we want to deliver really high quality performance on component level, on system level, on software level. So I'm excited that it turned out, taking in mind the years of effort that has gone into it, multitude of people from all disciplines involved. Really excited.
So Jolien, now I guess for you on the application side of things, what's different about going up, and using the Poseidon versus some of our previous benchtop systems?
Oh, the possibilities are endless. That's the nice thing about this X4 Poseidon. We have so much flexibility in comparison to some of the previous and other systems that whenever you want to scan some type of sample, it doesn't really matter which one, but any type of sample, you put it inside, you have
granted, say, multiple ways to scan this, but you can really optimize it for your sample to get a very fast scan. I really have to say, it really surprised me how fast we can actually scan. Um, in a very good quality to even a super high quality as well if you want. So the versatility is astounding.
I know one thing that's really, I guess, hit me has been that I've been used to using our 2214, and that's the system that is like, I think it literally weighs a ton. And it's actually there's one actually right behind me, kind of behind us, I should say, right there. And yeah, I mean, yeah. Sorry for the noise. That's actually that one. And yes, I mean that one you can achieve the best resolution. You can go submicron on that thing. But that being said, it's like the Poseidon just seems to really fill a broad scale of application. To really good resolution, but also that full size, full field of view thing. And of course, yeah, if I want to go to 500 nanometers, I'm going to have to go to a system that has an open source where you can change the filament and do all these things. I think more and more, it's like just about every application that's been coming through the door here, I want to throw it in the Poseidon first.
Hey, John,
Yeah.
there are a lot of questions about exactly this topic, right?
Yes.
So what does it do? What does it allow? How big are the samples? What is the resolution? How do you define resolution? Shall we?
Yeah, let's go
Take some
ahead.
questions.
Let's take some of those questions here. Well, let's start off with this one. What are the maximum dimensions of samples that can be scanned?
Jolien, I think you scanned pretty large samples for life science, right? Can you comment?
Well, yeah, I've scanned a wide variety of things already because, application scientists, we pretty much like to put anything inside the system that we find. So yeah, I did a quite variety. I haven't pushed the system to the limits yet, I think. But it really depends on which resolution that you want, of course. So the higher the resolution, of course, still the smaller your sample has to be. But you can get up to 110 millimeters, in this case diameter, and then 300 millimeters tall. So that's quite a view that you have, quite a range that we can put in.
Or a bench top, that is, Jolien, right?
Definitely.
I mean,
Pretty awesome, right?
Yeah, so I mean, like Diederik had said, I am just trying to go through the list here. By the way, I'm sorry if we don't get to every question. There is just so many questions here. We will answer these later, in case we don't get to them. So like I said, a lot of questions. Now, one question I saw in here, I'm trying to find it. This is a very interesting one, and I think Jolien, you may be able to answer this one
All right.
nicely. Can we say that the new system is a combined 1272 and 1275? For people out there who might be new to the area, 1272 that was our benchtop high res, 1275 was kind of the benchtop flat panel system.
So yeah, for sure, we can definitely say that. It depends on which configuration you have your X4 Poseidon, because it is a fully configurable system, as we've mentioned, or as you've seen as well in the videos. So it really depends on how the system is configured. You can have a 1275 like X4 Poseidon. You can have a 1272 like Poseidon, X4 Poseidon. Or you can have then both of the detectors there as well. And then you have like a level more even, because then you both have the big flat panel and the scientific CMOS there. So it's really, yes, of course. It is a successor system. So for sure.
but I have a question to that, if I may, because Joris and Kjell, I think we didn't just aim to replace both systems, right? So can you comment on what enhancements we added to the system compared to the 72 and 75, please?
Happy to take that one, Joris, and feel free to add. It's really, yeah, indeed, we are covering the possibilities from 1270 to 1275, but really extend. If we compare, for example, to the 1272, people that have a 1272 might know that the camera assembly can be put in a far middle near position, but you were limited to 3 different preset positions. With the Poseidon, there is no such limit anymore. You can really configure it or put the camera assembly in any position you want and fine-tune or strike the perfect balance between field of view, scan speed, and resolution. So that's one thing which is a big improvement. The other thing is the sample changer, for example. For the 1272 and the 1275, the sample changer is on top of the system. If you're 2 meters tall, just like I am, that's not a big issue. But if you're a bit shorter, then it makes much sense to position that in front of the system, and that's what we did. That not only has the advantage of being more accessible, but you can also simply cover it up and leave the sample changer in place while you are doing manual scans or using external stages. Maybe closing off with the software, which is also completely redeveloped from scratch. We have now a database management system. We have a user management system. For people across the world, we have multi-language support. So you can turn the system, or at least the software, into Japanese, into Chinese, French, German. That is really very exciting, I think. You are still muted. There you go.
We've got a question for Joris. So, what is the X-ray energy range in the X4? Is the beam stable below 40 kilovolts?
But the X-ray range is on paper 40 to 100 or 40 to 110 kilovolts. It depends on the configuration that you choose. There is no guarantee that below 40 kilovolts you have a stable X-ray output. That is not guaranteed. That doesn't leave a way that you can try it at your own risk.
All right, and I have actually, and I actually was running something at 30 kilovolts, and it seemed to work, fine for what we were doing there. So, like Joris has said, we're always very conservative in our estimates on where the system can be used. But the great thing about our solutions is you can kind of push it into places. So we are kind of coming to our end of the time today. I do want to, and we're going to have two things here at the end. One is I have one more question, and I'm going to throw it at this guy. Because everybody who watches our normal Live from the Lab show knows I don't like asking easy questions. I like to see people squirm a little. And then we're going to go around and just get some thoughts from everybody. And then at the very end, after this, everybody out there who's watching, you'll be able to switch over to the session, and we're going to show you this thing in action. So the last question for you. You don't have to answer it like with a specific number here. Oh, but we got a lot of questions. I think this is very important to establish. Mm-hmm. What are we talking here? Like, is this thing $1 million? Is this thing $5 million? Is this thing like cheaper than that? Like in terms of the spectrum of pricing, what are we talking about? Like I say, we don't need a definite number, but I think we need to establish this is a benchtop tool. This is an accessible tool.
So the beauty of the X4 is this configurability, right? And I was so pleased to see so many Skyscan users that use our systems already in the chat, asking very specific questions about how it compares to their current system, what the extension of the capabilities are. And I'm very happy to be able to say now already to everybody that uses our systems. So the entry-level system is really close, really close to what you would have paid for a 1275, which is really a low barrier entry into the microscopy market. Yeah. So that system would be very comparable to an entry-level SEM system that you would buy. Yeah. And of course, if you expand the possibilities, there are quite a number of options. Then you go to the realm of a real good SEM system, a floor standing SEM system. So I think so this was one of the design objectives to make it accessible, not only accessible in terms of hardware and software, but accessible in terms of every second lab can afford one.
Yeah.
So we are looking forward to that conversation.
So, and you can either reach out, go to our website, broker.com/X4 POSEIDON, or head on down to the expo here in our event. You can contact one of our specialists, and they can get you an exact number on what these things are going to cost. So with that, and again, thank you everybody for the questions. I think what we'll do is we'll compile these into a nice FAQ document, and we'll send that out in response to everybody joining. We're going to just kind of go around the room. I just want a final thought from each person. Let's start with Yolene.
I have many final thoughts. It's been such a fun system to use. I'm definitely looking forward to developing and looking into more applications to see what more we can do, and also for the people that eventually get one to actually train them on it and to see the future of what they will be doing. So I'm definitely that's going to be my point of view for now, I think.
All right. And then Joris, let's hear your final thought.
Well, I'm also excited by the future, but let's say on the technological level, it's a platform, both software and hardware. That means we can introduce a lot of new things in the coming months, years, that will just push the boundaries even further, which hopefully will then be used by application and our customers in the end. So I'm excited to develop those things with our team.
You know, it's a journey and we are still on it. Kiel.
I'm very thankful to all people who joined and who took the time to listen to us and to watch our new development. We've done a lot of scanning already, and we're very excited. I'm looking forward to receive a lot more samples from you guys and allowing us to further test the equipment and really push to further limits. Thank you.
All right. And once again, just to reinforce, after this, head on down to the session, see that live demo, or go down to the expo. And with that, I'm going to leave you with the final thoughts of Diederik.
So everybody, I want to thank everybody, first of all, for joining. All this interest is really encouraging for us, and I hope that you can see our enthusiasm. So this has been a very long journey for us. And what we've done is we've not just developed a successor of what we already have. We've started a new generation of Bruker X-ray platform. And you can be sure that this system will not be the only X that we will introduce in the near future. So we are ready. Our labs are equipped with the X4. They're all running. So contact us and we would welcome you with your samples in our labs globally.
All right. Thanks for joining, everyone. And we'll see you in the session. All right. Goodbye.
Thank you.
Bye.
In our offices in the beautiful state of Wisconsin. My name is Stefan Leroux. I'm the product manager for the XRM division. For the material science side, and to my right here, we have our application side is Billy Reese. We will be showing you today what this amazing product of ours looks like.
Absolutely.
Yeah. So I just want to let you know this is a more laid back, interactive session.
Yeah.
And we would really like you guys to interact with us. There's you'll see on the right-hand side, there's a section where you can ask some questions. Please, and I'll try my best to keep an eye on them so we can talk and just discuss what's going on. And through that. So what some of you might not know is that Billy over here used to be one of our customers before he started at Bruker.
Yep.
And Billy, so from your perspective, what are you looking forward to in this new product? Some of the interesting features are excited about?
So what's been really fun for me, and as Stefan mentioned, I'm just started less than 4 months ago. I'm just over 3 months. What's been really exciting for me is I love the feel of the new software, which y'all are going to get to see. We excited to show you the new software for sure. Another thing, my experience with other systems I've used in the past, I keep feeling like these scans with this system should take longer. They're so much faster. This flat panel is amazing. The system is amazing. I'm loving this new system. It's been really, really fun for me to use. It's been really, really fun to watch the development as well. It's been great working with the team, with the development, and just the whole process from start to finish has been awesome. And the system it's phenomenal.
Well, we tried our best to make it as accessible as possible. And I'm very excited to see some of these features you've spoken about. So Billy, if you could, let's have a bit of look at the software. I mean, let's have a look and see what you've got cooking for us today.
Yes, sir. Let's do it. Okay, so we're looking at the new software, and as you can see, the layout is completely different. It's an all new feel. Right off the bat, let's just go ahead and get logged in here.
So Billy, you're talking about log on there. So
yes.
How does this work? Do we have users? What's the concept there?
Yep, great point. So the good thing is you have so each user can have their different, as you can see here, my role is an engineer. There'll be different roles, and the different roles can have different levels of access to the software. As I have logged in now, you can see there's a good breakdown, a good awareness of what's happening with the system, so you can kind of keep an eye on everything. But the different user levels is really what's key here.
So you're telling me that basically you could assign different roles of different users, which will now only give them access to their own data and not anybody else's.
Correct. So each role will have different access levels, including access to their own data. So you're not, so as person A logs in, they have access to their data. Person B logs in, they only have access to their data. So less confusion and less complications with that.
And with these different user labels, you can assign, for example, a more experienced user can get access to, let's say, for example, all the functionality. Whereas if you have less experienced users, you can cater more to what you think they would be
correct.
able to. Yeah.
Correct. And as we move, so let's as we move in, there's something on that note that's going to be really interesting.
Okay, great.
So the data management portion of this is also something that's been really nice. So we will open up this project, which depending on what your lab setup is, you can define what your project is, and then define the various levels. So then we'll open up the study. As you can see, you saw in the videos, this might look a little familiar to you. So now, as we moved into the acquisition portion here, you'll see, again, a whole new feel. And the first thing that Stefan was talking about here, scan protocols. So let's say you have users of various levels. Now, I have everything open here. But the first thing is scan protocols. The first thing you'll notice is the flow from top to bottom. We'll start there. So this flow is really, really nice. I really enjoyed having this flow set up. And then so scan protocols with the various user levels.
So everything is at your fingertips, basically.
Yes.
So you don't have to go look and scratch at all the sub-menus to get you where you need to go. You have a more detailed overview of what you need to do, correct?
That's right. That's right.
Great. That's amazing.
So with the scan protocols, with the various user levels, you let's say you have a user who's just a base user, not an expert level user. They come in, they know what protocol they use, they apply that protocol, scan starts, and they're good to go.
Great. So you've mentioned something earlier about a large field. Hang on, let's have a look at some of these questions. Hang on, before we start, let's have a look over here. Yes, the first question is asking from Marcus is the system making a 3D image of the whole specimen, which you would later look into, or you go to the spot that you want to look in situ? That's a good question. Yes, you can start off by doing an overview scan. And this is something Billy will show us now. The system has a very large field of view, which allows you to capture the entire sample in a single scan. And on top of that, you can then zoom into individual features of regions of interest, and then extract that information much easier. I think, Billy, that's a good point to go over to show us what this field of view looks like.
Yep, absolutely. So let's go ahead and turn this on. So X-rays are on. This might look a little familiar from the videos. And I'm going to open up a few boxes here. So we have the X-ray source, and so you can enter your KV current filter changer here. And again, we have the automatic filter changer on, which is really, really nice. No opening the door to be able to change that filter. X-ray camera, I'm currently on the flat panel. And then we are currently at the flat panel with the detector move all the way back.
Right, so we're basically at the largest field of view that we can achieve.
Correct.
So we're looking at all the way back.
Yep, we're at 40 microns resolution here, and you can see just how much space we have. This field of view is massive. And then something I would like to also point out is we're at 250 milliseconds here. So even with this, like if we were in this scan right now, it's a 20-minute scan at full field at this massive field of view. We're not even optimized with the sample in the full screen.
So I saw something earlier in the video. We're talking about best scan geometry.
Yes, sir.
So we know with this function we've added, we now in the past we had, so depending on the setup of the scanner you had, you could have either a fixed geometry with a source and detector or at a fixed distance, or you could have more. You had some movement of the camera, but you were a bit more restricted in that sense. But now, with the base scan geometry, we've added complete variability in all the movement, not just the stage, but also the camera. Cameras can move forward and backwards to allow you to always achieve the best scan settings possible. So Billy, can you help us to show how this will impact speed, for example, when we set up a scan compared to what you've got over there?
Yeah, let's play around and let's move the sample around and see what kind of images we can get. So as Stefan, so this is full field of view that Stefan was mentioning. Let's see. So I know we're gonna let's get this starfish in the full field of view here. So all I did, type on the pixel size here, 16 microns. That's gonna be the full field of view. And another good feature is, maybe I don't necessarily like this. Let's center it a little bit so we can move it down really easily now. And so now we have our starfish nice and full field of view really quickly, and that's moving. Now we're moving the sample closer to the source.
Yeah, so applying some magnification, yes.
Yes, applying some magnification, but we're still at 250 milliseconds. So with the best scan geometry, one of the things we can do.
So what are you moving there now?
This will be I'll be moving the detector closer to the sample.
So to the source, basically.
Yes, yes.
Okay.
So I'll be decreasing the source and detector distance.
Right.
So we'll do this, and look, look at the screen is completely saturated, right? So,
but why would that be?
Now you have the detectors being oversaturated with our exposure time. So this means we need to decrease our exposure time. So as something you saw in the video, you can scan 4 times faster with the system now. So I'm at 250 milliseconds. Go down to 60. And boom, there you go.
So now each individual projection image is captured 4 times faster.
Yeah, and so this is like, again, like I was saying, I'm blown away by how fast this is. Now we're at a 4-minute. This is a 4-minute scan for
compared to 20 minutes before.
Yep.
Wow, amazing.
So, and this is a full 360-degree scan. So
Billy, how has that impacted your data collection habits recently? Because in the past, you were sitting around for hours waiting for samples to finish.
Absolutely.
And now it seems like you could be done in the morning.
So I used to save all my fun scans or my exploratory scans, technique development scans. I would save those and I would stack them up and I would run them over the weekend because it would take time. And if I was doing it, at work, I'm just sitting around twiddling my thumb. Like I have time for naps.
Okay, so we're keeping you busy then with that.
Right? Yeah. See, now the problem is I can now run all these scans. I can set up multiple scans. I can run 4 or 5 scans overnight. Okay. And it's almost too much data for me to process.
Well, I mean, the more data we can collect, it's right? Yeah. Let's look at some of the questions you guys have. Looks like we have from Jerry. How about post-processing analysis? Are there software upgrades that make analysis automated easier, quantitative beyond the current data via CTN? With the new software package, there are different ways of interacting with your data. And of course, you also offer additional software packages where you can do analysis. So there are different tools available to you that you can, when you are speccing out your system, which we hope you do, you can also spec out what additional software you would like. So that is also an option. And let's have another one. It says here from Marcus, I work in material science with cemented carbides, tungsten carbide, cobalt, system feasible as a non-destructive quality control, especially tungsten has high absorption. About the right term, I hope this is the right terminology. Yes, you're right. So the system is quite flexible. And this is one of the great things about it. Depending on sample size, yes, tungsten is quite absorbing, this we know. But if you have smaller samples, you can optimize the scanner to achieve amazing resolutions for the different sample types as well. So yeah, these are things that we can look into. But on that topic of samples, I want to mention something to you, and this is something I would love you guys to go to the website and have a look at, is that at launch today with the website being live, you will see there's a section of app notes. So the applications teams were working extremely hard the past couple of months to generate application notes with specific examples of some of the industries we are sure this instrument will be amazing in. And there are 16 at launch spreading over material science and life science. And we will be adding more as the months go on. So please go to the website, download them, show them to your colleagues, and then you will get all the information you need from there. I'm looking forward to see you guys and hope you enjoy the website, which we work very hard on. So now we just want to go into the next thing. Like we've talked about the best scan geometry now, but also it seems that we need to be able to strike the best balance between different features of the machine. Field of view, resolution, and speed. And we've spoken about geometric magnification plus. So Billy, can you explain a bit about that and how that can be used in the Poseidon, X4 Poseidon?
Yeah, so we can look into that for sure. So
Great.
So we've seen this, we've seen being able to, so remember we were at the same resolution, so we're at 16 microns resolution with the detector all the way back. Now we're...
With a flat panel, right?
Yes, sir, flat panel.
Okay.
And so now we're at 16 microns resolution with the detector as close as it can go. So this is 4 times faster.
Perfect. So in the scanner, do we have, how many cameras can we install in the system? How does that work?
So this system has 2 cameras. So we have the flat panel here, which I absolutely love, and we have the CMOS. So let's take a look. Let's get this. Here we go. Let's do this.
Okay, so what you're going to do now is you're going to show us how the combination of 2 cameras in the scanner can be used together to strike the perfect balance between the best scan settings for your sample, correct?
Correct. And so one of the nice things here is you can see that now we're going to start moving in. And one of the nice things here, object radius. So you can also, I know some of y'all might have got a little nervous about me moving the sample in like that. You can put your object radius and you can make sure and protect the source so you're not running into anything. But let's go ahead and switch from the flat panel to the CMOS. And so one thing you can see here is you can see, I'm changing the exposure time. I'm sorry, that was too much. So you can start to see a nice level of detail here. But let's change to the CMOS camera and see what kind of resolution we can get.
Billy, on that topic of what you're busy with at the moment, there's a question here from Sanil asking, how is the magnification control in X4 and what is the maximum achievable zoom? Please explain with comparison to 1272. That's a great question. So in the 1272, for the people that have used the scanner, is that the camera could also move. However, it had fixed positions and the software controlled that positioning for you, and the user could not specify where the camera is positioned to optimize for the scan they would like to do, resolution, speed, or field of view. With X4, what we've changed is you have complete freedom of movement of the camera, which can be positioned anywhere between the sample source and positioning, which allows you to bring the source closer, for example, to increase the scan speed, or move it backwards for best resolution, or you can use a combination of these two by switching between the cameras, which will allow you to achieve even better image quality. And I see there's another question here about from Megan asking, can we work with applications team to have them do a demo on particular samples? Yes. Like you can get a demo similar to what Billy's doing right now. We can show you the instrument, you can look at some of your samples, but if it's not possible to come here, of course, you get the app notes. You can also see some of the examples we've done before and how that can potentially work for you. And if there's anything that we haven't done, we would love to have you visit us and come see how the system works. So Billy, let us see how that works.
So while we were answering some questions, I got this. So we're looking at, let's see, let me turn this on. This is the flat panel image that I took, right? So let's go ahead. I switched over to the CMOS here, as you can see, but I haven't turned it on yet. So let's go ahead and turn on the images. And I would like y'all to look at a next level of detail here. Sorry, exposure time is a little high. Here we go. There we go. All right. So what's really awesome to see is this level of detail that we get. There we go. There you go. So now with the CMOS camera, we're looking at an entirely new range of detail. So if you're curious about the different, and notice that there's 2 detectors inside the system. We're not having to physically change detectors out. Both of them are inside of there. So depending on what you're scanning, if you realize you need that higher level of detail, that higher level of resolution, you never know what kind of detail you're going to be able to unlock. And it's been a joy to use with this system.
Thanks, Billy, for that great demonstration. I can really see that this will be a useful tool for multiple different applications. As we said, the idea for the X4 Poseidon is to have this benchtop system in any lab, which means that it will be you could be able to use this for any samples. And talking about samples, something that you mentioned before about the high throughput, and something I want to point out behind me is you'll see attached to the front of our scanner, we have our sample changer. And I see, Billy, at the moment, the low profile lid is installed. Can you give me some update as to why you would be doing this? What is the advantage of having the low profile lid installed compared to the normal one?
So something you may be familiar with our older systems, the sample changer was attached to the top of the system, and it made the cabinet, you couldn't access the inside of the cabinet. So with this new system, it attaches to the bottom of the system. It's very slides on, latches in, you're good to go. So much easier to install, 15 sample positions. And then when it's running, when you're using it, it'll have a different lid on there. But now with this low profile lid, we can access the inside of the cabinet without having to take the sample changer off. So you can use it with or without the sample changer active. You don't have to remove this if you don't want to.
So if you, for example, if you have a larger sample you want to load, you can just put the low profile lid on, put the bigger sample in, do the scan, and you can still continue afterwards with doing your sample changer.
Compression tensile stages as well.
Of course, 4D CT. Yes, it's flawlessly integrated into the system as well. We have got some of our materials testing stages you can add. Yes. Amazing stuff. Right. So I'm going to have a last look over here. Some of the questions you guys have. Let's see before we end the session. We know everybody's quite busy. We want to make sure that you have a great day. So there's a question about, can we talk about optics inside? Yeah, well, as we mentioned before, the optics inside the system, we have 2 cameras. And you will also have the option to equip 2 different sources. So for example, if you want to go to the highest resolution, there's a transmission source option. Or when you are looking for a higher power, more throughput environment, you can go for the reflection source, which is more the workhorse system. And you can, depending on your application, you can choose either the high resolution CMOS camera, or you have a larger field of view flat panel, or both. We're not restricting you to a single camera. And of course, you don't have to go for that camera, or both cameras from day one. You could, for example, order the CMOS to address certain applications that you have right now, which might be high resolution. Or you could then later on, at your lab, a service engineer could come and you could upgrade to a CMOS. The flat panel can be installed for you. And then you'll have the full functionality of Gen Plus to switch between the cameras. And it's an amazing tool.
Yeah, I think that's been one of the beauties of this is I wanted to, like, being able to build the system the way you wanted to build the system, being able to optimize the system, switch things in and out, add things as you go, as your budget allows, or whatever it is. As your projects change, you can build it out how you want to build it out, which is amazing.
Great.
Variable source detector.
So there's a question.
So sorry. Let's answer this question. So this variable source detector distance and exposure time options do require extreme time of detector calibrations before it's. So they don't actually. So the system will be calibrated when it gets on site, right? So of course, like the system will be calibrated, but as far as the calibrations of the picking your exposure times, so we still have the. Actually, can we demonstrate this on the software?
We could.
So again, what we have here, one of the great things in this software is being able to do your flat field corrections. And so you can have the system auto adjust your exposure for you if you want. So it'll move the sample, which some of you might be familiar with this from our other systems. So auto adjust the exposure, it'll move the sample out of view. And so you can have it do it for you. So it's actually, it doesn't take too much extra training. It takes your standard training, but it doesn't take an expert level to understand or calibrate or get the correct image quality.
So let's see if there's a couple of additional questions over here. Michael, what are thickness limitations for scanning through metallic samples, aluminum, steel? So based purely on physics, the denser an object is, the more X-rays are absorbed. The smaller the sample will need to be able to scan it. So if you go to the lighter metals like aluminum, for example, you can scan larger samples. So we're talking about if you want to steel samples, can be scanned in the couple of millimeters range. But if you want to scan aluminum, it can go a bit larger. So you'll need to. This is where for example, you can contact our amazing applications team. We'll be able to guide you and help you to show you what are the capabilities and what are the possibilities for the system. Right, let's have another question over here from Sanil. For a given pixel size, does the auto sample changer automatically recognize the sample position and start the scan? Yes. So, for example, you could, when setting up a scan, indicate on the samples on the sample changer which position is loaded, and then that sample with its settings will be loaded in, scanned, and positioned around. So yes. Let's see, another question there from Danilo. Just a question regarding alignment. What changed from the previous system? Alignment. The alignment of the system, as all CT systems need to be, is the source detector and sample need to be aligned during scanning. And used in this system, and this is especially for high resolution, we have a micro-positioning stage on the rotation stage itself, where you can within the control software, you can click and drag. And Billy showed this earlier, if you noticed. He clicked and dragged an arrow across the screen. You can move the object to any position in the field of view to make sure that you're capturing exactly the right area for your analysis. Right. And lastly, I just want to thank everybody, and thank you, Billy, for taking some time out of your day to showcase what this amazing machine can do.
Absolutely.
I want to thank everybody who joined today, not just for the demo session, but also for the launch event. Thank you for joining us today, and we're looking forward to seeing you in our labs and having interactions with you, and have a great day.
Yep. Thank you.
Bye-bye.